Welcome to Study Loop.
Okay, so we have copper nitrate and it's aqueous, right? So it's been dissolved in water. And specifically, we have 3.38 grams of our copper nitrate. And we are told that we have made a 0.220 molar solution. So, what's the volume of our solution? Okay, well, how are we going to do this? Well, I think it's best to say, okay, start from this molarity, right? What is molarity? Okay, the units of molarity are 0.220 moles per liter, right? So that's a volume, right? That's kind of what we're looking for. This volume here. What goes down here, right? What did we put? Uh, how many liters do we need to get a specific amount of moles? Okay, do we know moles? Right, so this is going to be equal to some number of moles over some number of liters, right? And we're going to want to find this liters, but we need to figure out what this moles is first. Well, we don't know moles, but we do know that our solution has 3.38 grams of copper nitrate in it. And if we know the molecular mass of copper nitrate, which is 125.55 grams per mole, then maybe we do know how many moles of copper nitrate are in our solution, right? In fact, if we divide 3.38 grams by 125.55 grams per mole, right? Grams divided by, let's try that again. Grams divided by grams per mole will give us units of moles. That'll tell us how many moles of copper nitrate we in fact have, right? So this is actually telling us how many moles we have. We simply need to do a little division. 3.38 divided by 125.55. So 3.38 grams copper nitrate divided by 125.55 grams copper nitrate per mole copper nitrate tells us that we have 0.02692 mole of copper nitrate. Okay, well, now we know how many moles of copper nitrate we have, right? So if we know that, and we know that our molarity is moles per liter, right? Then at this point, we're saying we know that 0.220 is equal to 0.0, yeah, 0.2692 divided by some number of liters, right? So we can solve for liters, right? We do a little bit of algebra. We multiply both sides by liters. Our mystery liters, let's just call it X liters, I don't know. X liters, okay? And then divide both sides by 0.220. Okay, liters will cancel here. 0.220 will cancel there. We'll get X liters equals 0.02692 divided by 0.220. How many liters have we got? Zero point 1224 liters, right? And if we want to obey sig figs here, in fact, we would say that we have 0.122 liters or 122 milliliters, right? And we could check our answer as well. We should know that if we take the moles that we determined and divided it by the liters that we determined, we should get the molarity that we had determined, right? Which may not be such a bad idea. In fact, that would be maybe another way of doing the question, right? So if we know we have a molarity of 0.220 moles per liter, we could rewrite this as 1 over 0.220 liters per mole. And we would multiply this by the number of moles that we got when we converted grams to moles, which was 0.2692. Right? And get our answer that way. Moles would cancel with moles. We do the same math, right? And then we get our final answer of 0.122 liters. So either method of solving the problem is fine. Maybe the second one is a little more straightforward. The hard part is recognizing that you have to flip this before it's useful, right? Because it's currently in moles per liter, but you need liters in the numerator if you're going to end up with liters as your unit in the end.